Guys, welcome to Distance Learning with Lee, where I make learning mathematics super easy. I'm actually excited for today's video tutorial because we are dealing with question 4, right, of the grade 12 mathematics June 2022 paper 1 that was written by the Gauteng province learners, right? And in this video tutorial, guys, we are dealing with functions, right? It's a function and it's a hyperbola, right? So please make sure that you watch this 2 video tutorials. This is the part 1 video tutorial and this is the part 2 video tutorial that you guys can watch, and these 2 video tutorials will help you understand everything that you need to know when it comes to dealing with the hyperbola, right? I tell you guys how to find the domain, how to find the x and the y-intercepts, how to find your axes of symmetry, how to find your asymptotes, right? It is a great video tutorial, and also how to sketch your hyperbola given the formula of your hyperbola, right? So please make sure that you watch those video tutorial, guys. And if you watch that video tutorial and you've taken down your notes, then you're ready to watch this video tutorial, or even just use this video tutorial as a way for you to just check to see if you understand everything that I've explained in that video tutorial. So before we get started with the video tutorial, please make sure that you are subscribed to Distance Learning with Lee. Please make sure that you also give this video tutorial a huge thumbs up, so you click on that like button, and also make sure that you click on that notification bell, because we are doing term 1 and term 2 revision right now on this channel. So please make sure that you do not miss any video that comes up, because it will really help you guys to prepare for your final exams. Guys, the final exams are here. You don't want to be studying for final exams the week before. If you want to pass, if you want to get distinctions, if you want to get a good mark that is above 60, you start now. You don't start the week before. All right. So guys, without any further ado, let's get started with today's video tutorial. Question 4, guys, we are given f of x, which is equal to 8 over x minus 2 plus 2, right? Guys, from here, you should be seeing that this is actually a hyperbola, right? This is a hyperbola, right? If you can't see that this is a hyperbola, guys, please make sure that you watch this video, okay? A hyperbola is given in the form of f of x, which is equal to a over x plus p plus q, okay? So this function is in that form, so we can see that we are actually dealing with a hyperbola, right? 4.1, write down the domain of f, right? Guys, remember, to get the domain of f, you basically need to focus on this expression, right? And we know that that expression cannot be equal to 0, because the minute that expression is equal to 0 at the bottom, or the minute we get a denominator that is equal to 0, we are going to have an undefined value, okay? So we don't want that. So that is where we are basically restricted in the denominator. X minus 2 cannot be equal to 0, right? So to get the domain, you focus on the denominator, x minus 2, and that expression cannot be equal to 0. Okay, because when it's equal to 0, it's going to be undefined, right? So x cannot be equal to, you take the 2 to the right hand side, x cannot be equal to 2. Okay, and therefore our final answer, x is an element of real numbers. So the domain is x is an element of real numbers. However, x cannot be equal to 2, right? So that is our domain. Question 4.2. Calculate the y-intercept of f. Okay, so to get the y-intercept, what do? You let your x equal to 0. To get y-intercept, guys, you need to let your x equal to 0. And when you let your x equal to 0, right, here's a function, right? We know that f of x is equal to 8 over x minus 2 plus 2, right? And we are saying that we need to let x equal to 0. Guys, we know that f of x can also be written as y, which is equal to 8 over, what is our x? X is equal to 0 minus 2 plus 2. Therefore, if you punch that into your calculator, you'll find that when your x is equal to 0, your y is equal to -2, right? So your y-intercept is y is equal to -2. When x is equal to 0, your y is equal to -2. 4.3, right? Calculate the x-intercept of f, right? Okay. To get the x-intercept, guys, what do you need to do? You need to let your y equal to 0, right? So our function is y, which is equal to 8 over x minus 2 plus 2. That is our function. We need to let y equal to 0 to get our x-intercept. So if your y is equal to 0, right, what is our x? X minus 2 plus 2. So it's going to be -2, which is equal to 8 over x minus 2. Cross multiply -2, multiply by x minus 2, which is equal to 8, right? So it's -2x plus 4, which is equal to 8, okay? And then when you simplify that, you'll find that -2x is equal to 8 minus 4. Okay, divided by -2, divided by -2. X is equal to -2. Okay, so when your y is equal to 0, guys, when your y is equal to 0, your x is equal to -2. Okay, question 4.4. Okay, sketch the graph of f. Clearly indicate the coordinates of the x and y intercepts as well as your asymptotes, right? So guys, remember, right, in the video that I did for you guys, I showed you guys how you get your vertical asymptotes and how you get your horizontal asymptote, right? So we said that the expression x minus 2, right? So the expression that's in your denominator, right? That expression there gives us what? Vertical asymptote, okay? Your value of your q gives us your horizontal asymptote, okay? So, okay, to get our horizontal asymptote, we focus on the value of our q, right? So that's +2, okay? So y is equal to +2. To get your vertical asymptotes, right? You focus on this expression here, okay? X minus 2 is equal to 0. That expression equated to 0, and you solve for x. X is equal to 2, right? So your vertical asymptote is x, which is equal to 2, okay? We already found your x-intercept, okay, which is -2. When x is -2, obviously your y is 0. And you also find your y-intercept. So when your y is equal to, or when your x is equal to 0, your y is equal to -2. Right? And then here, guys, what else do you need to know to be able to draw your function? Right? The value of your a. Your value of your a tells you which quadrant you are working in, right? We see that your value of your a is greater than 0 because your a is equal to 8, okay? And then from here, guys, we are ready to draw a function. Just gonna quickly draw the function here. We have a vertical asymptote of y, which is equal to 2. Okay, so our horizontal asymptote, right? Horizontal asymptote, okay, is y is equal to 2. So that is our horizontal asymptote. I'm just gonna highlight it with this yellow. That is our horizontal asymptote, right? Our vertical asymptote is x is equal to 2. All right. Please show this, your y, which is equal to 2, right? And then we know that we've got an x-intercept of -2. When x is -2, y is 0, so that is there. And when your y is 0, when your x is 0, your y is equal to -2. That is our x-intercept. And we also know that if your a is greater than 0, right, our function is going to be in the first quadrant, right? And in the first, so this can be 1. That's our first quadrant. That is our second quadrant. That is our third quadrant. and that is our fourth quadrant, right? So we're going to basically look at this yellow line as like our new Cartesian plane, right? Because our function has basically shifted, right? So basically, to make it easy for us to understand, I'll refer to that yellow line as my new Cartesian plane. And we know that this hyperbola, actually, this hyperbola is going to be in the first quadrant and in the third quadrant, right? And in the third quadrant, guys, we know that we've got what? Those intercepts there. So we need to take consideration. We need to draw them and show them in our diagram, right? So that is basically how our function looks, and you need to basically show all your intercepts, right? So what's going on there? X is equal to 0, y is negative 2. You need to show that, okay? So basically, guys, this is basically our sketch, right? You get your horizontal asymptote, and then you get that horizontal asymptote with that value there. The value of Q tells you about your horizontal asymptote. That expression in your denominator tells you about your vertical asymptote. You get the x-intercept by letting y equal to 0. You get your y-intercept by letting x equal to 0. And because we can see that the value of our a is greater than 0, that tells us that our hyperbola is going to be in the first and in the third quadrant in this new Cartesian plane. I'm referring to it as a new Cartesian plane because our function is basically shifted, right? But then, so basically that is like our new Cartesian plane, and this function is in the first, that's the first quadrant, second, third, fourth. So it's in the first and in the third quadrant. And remember, in the third quadrant, guys, we've got those intercepts that we need to include there, right? And we've done that, and that is basically how our function is going to look, okay? Next question, 4.5, we are told that y, which is equal to negative x plus k, is an equation of our line of symmetry of f. Determine the value of k, right? Guys, I told you guys, when you're dealing with a line of symmetry or axis of symmetry, we basically need to look at the point of intersection of your two asymptotes, right? So the two asymptotes intersect at that point there, right? At that point is when your x is equal to 2. I'll write it here. That point there is when your x is equal to 2 and when your y is also equal to 2. You focus on that point of intersection, right? And then we're already given the equation for basically our axis of symmetry, right? Okay. And they tell us that this equation for axis of symmetry is equal to y, which is equal to negative x plus k. And we need to find what the value of k is, right? So since we've basically, to find the equation of your axis of symmetry, you need to focus on the point of intersection of your two asymptotes, right? And your two asymptotes intercept at that point there, 2, right? You substitute the x value into this equation, and you substitute the y value of that point of intersection into your axis of symmetry equation. So your y is equal to 2, which is equal to negative, and your x is also equal to 2 plus k. And you find what the value of k is, right? And from here, guys, you will see that 2 plus 2 is equal to k. So k is equal to 4, okay? So you found that your k is actually equal to 4. Therefore, the equation for our axis of symmetry for this hyperbola is given as negative x plus k, right? But now, since we found what the value of our k is, we are just going to substitute that value into this equation. So minus x plus 4. So that is our equation for our axis of symmetry, okay, or the line of symmetry of this hyperbola, okay. So in other words, our k, because they just wanted the value of your k is equal to 4. And the last question, determine the equation of the graph which is formed if f is shifted 3 units to the right and then reflected across the x-axis, right? I love this question. This is 4.6. Okay, so our function, our original function, this is 4.6, guys. I'm going to do it here. That is our function, 4.6. We know that our hyperbola is given by the equation f of x, which is equal to 8 over x minus 2 plus 2. Okay, we are told that this hyperbola is actually shifted 3 units to the right. Right? So we've got a horizontal shift, okay? And then it is reflected across the x-axis, right? So when you reflect something about the x-axis, right, what happens, okay? If you reflect something about the x-axis, this is our x-axis. If you reflect something about this axis, what changes? Your y values change, right? So the first thing we're going to do is we're going to focus on that reflection that we are told about, right? So we are told about a reflection, okay? And you need to remember, when you're reflecting something about the x-axis, right, the y values change, right? So y, this function can also be written as y, which is equal to 8 over x minus 2 plus 2, right? So your y changes. So how do we show that, right? The y is going to be negative y, which is equal to 8 over x minus 2 plus 2, okay? So that is the first thing that's happening. Né? The second thing that's happening, we are being told that this function has basically been shifted 2 units to the right. Okay, actually 3. To the right. So what does that mean, right? If it has been shifted 3 units to the right, guys, we know that it's a horizontal translation, right? So we focus on that x minus 2 expression, right? X minus 2 is the same as saying x is equal, which is equal to 2, right? But then we know that it has been shifted 2 units to the right. So, 3 units to the right. Okay, so x is equal to the 2, the original 2 that we had there, plus the 3, because it's moving 3 units to the right. So you plus 3, right? So x is going to now be equal to 5, right? That is going to be our new vertical asymptote, right? And if you just write that as an expression in a form of x minus something, it's going to be x minus 5, which is equal to 0. So if you put that back into your equation, right, then we know that this function is going to look like this. You'll have that reflection about the x-axis, 8 over, and then we've now also included that 3 units shift to the right, which is x minus 5 plus 2. And then, guys, we're going to get rid of that negative there, okay? That negative on the left-hand side, we need to solve that, right? We've got negative y, which is equal to 8 over x minus 5, right? Because we have now moved this function 3 units to the right, plus 2. Okay, and then from here, if you divide right through by the negative, y is going to be equal to negative 8 over x minus 5. And then negative 2 divided by negative 1 is going to be negative 2. Okay, and guys, that is basically our final answer. Okay, so if this function has been reflected about the x-axis and it has been shifted 3 units to the right, that is what our new hyperbola is going to look like. Okay, guys, so we've covered the whole of question 4, which basically dealt with the hyperbola. Please make sure that if you were lost at some point somehow, please make sure that you watch this video tutorial where I explain the properties of a hyperbola. It will really help you guys, right? It was easy for us to get the domain of the function because we said that to get the domain, we focus on the expression in the denominator because that tells us where our x values are restricted. Okay, to get the y-intercept of our function, we let x equal to 0. To get the x-intercept of our function, we let y equal to 0, all right? Then we're able to basically sketch the graph, okay? Because to sketch the graph, what do you need, guys, right? You need to be aware of what the a value is, right? And we saw here the a value is greater than 0. You need to find what the vertical asymptote is, right? And then you also need to find what the horizontal asymptote is, right? We did that, okay? Once you find your vertical asymptote, horizontal asymptote, and your x as well as your y-intercepts, right? Then you'll be able to draw your function. And then lastly, for 4.5, if you want to get the equation or find what the equation is for your line of symmetry, guys, you need to focus on the point of intersection of your two asymptotes, right? With that point of intersection, you need to substitute the value of x and the value of y into this equation to get your k. And then once you get your k, you can just simply substitute that k back into the equation to get the equation for your line of symmetry. Okay, and in this case, we found that your k is actually equal to 4. Okay, and then lastly, determine the equation of the graph. If the function is shifted 3 units to the right, if a function is shifted to the left or to the right, guys, you need to remember that is a horizontal translation. So we need to focus on the horizontal, right? And if it's shifted 3 units to the right, you can simply say x is equal to 2, right? But if it's shifted 3 units to the right, you just plus that 3, okay? And then x is equal to 5, and then you can simply take back that 5x minus 5 is equal to 0 and put it back into that equation, right? And then last thing that we had to also realize here is that we had a reflection across the x-axis. And what you need to remember that if you've got a reflection about the x-axis, what actually changes? The signs of your y values change, right? So that is why we have basically now substituted a negative y into the function. And then from there, we were able to then solve our equation, or basically isolate this y by dividing all the way through by a negative. All right, so guys, I hope the tutorial helped. Please make sure that you guys are subscribed. Like I mentioned, guys, we are doing revision of our term 1 and term 2 work, guys, so please make sure that you are subscribed to the channel, because I am going to be hooking you guys up with the revision. I want us to start with term 3 work by the time that you guys get back to school. Okay, so guys, please make sure that you are subscribed, and also don't forget to make sure that you give this video tutorial a huge thumbs up, guys, and I'll see you guys on my next video tutorial. Guys, we are tackling question 5, and question 5 deals with an exponential function and a quadratic function. It's fun. Okay, so I'll see you guys then. Don't forget to subscribe and like the video tutorial. Also, don't forget to share the video tutorial with your friends. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.